Hi everyone, today's topic of discussion is parabolas. So certain definitions. First of all, as a section of a cone, we've already seen if I take a cone and I make a vertical cut, then the cross section I get is going to be like that in shape. Yeah, so the cross section is going to be parabolic in nature. Now that's good and all for understanding where parabolas arise from in a cone. But to find an equation, we need a geometric definition. Now remember, the definition of a circle was given a one point and given a distance, set of all points which are equal distance from there. Right? That's how we ended up with a circle. If I give you this point and I give you this distance and I say what are all the points which are same, which have this distance r from this, it's going to be you mark out all of these points and you connect them and you get a circle. So there's a similar definition for parabolas, except slightly complicated, not too much. So it says the set of all points equidistant from a line and a point. Right? So compared to the circle, these are set of all points which are at an equal distance from one point. For parabola, we are saying that I take a point and then I take a line and then I ask, I want points which are equal distance from both of them, right? So one of the possible shape is right here in the middle, midpoint. And then what happens? If I'm to move right, if I move parallel to this line, I'm going to be too far from this point. So I gotta sort of follow in an arc so that this distance and this sort of keep matching up, and similarly on the other half. And when I do that, the shape that I get is a parabola. What this is saying is, I take any point, then this distance and this distance perpendicular from the line are equal. Any point, this distance and this perpendicular distance is the same. Any point here, this distance and the perpendicular distance is the same. And this one is special because then this is just the midpoint. So when you apply that condition, the shape that you get is a parabola. Okay. So you fix a point, you fix a line. The purple is a parabola. Those are all points equal distance from the point and the line. And now we have some important points here. Focus is called the fixed point. And the fixed point is called the focus. The fixed line is called the directrix. The axis of symmetry is, this is a line perpendicular to the directrix passing the focus, which is the fixed point. So a line perpendicular to directrix passing through the focus. And then the vertex, we have a very much more formal definition here. It's the intersection of the parabola and the axis of symmetry. Now it makes sense why this is called axis of symmetry, because if you flip around this line, then it remains the same, the parabola. So the new words here are focus and directrix. Later on we look at an example as to why we call this point focus. Directrix is just saying that it's I don't know actually why it's called directrix. It's something you can look up. So those are some of the important terms. So with that geometric definition, let's try to find the equation of this parabola. What do we know is, so we start with a simple case and the vertex is at origin. We know that this point on the purple line is equal distance from 0p, the focus, and from directrix y equals negative p. Okay, where p is a variable. Yeah, try and label the different colored objects here. The blue line is a directrix. The blue point is the focus. The purple is the parabola. And this is the vertex right here. Okay, so what we know is the distance of P to F is the same as distance of P to this line. Let's do the right hand side first. This point is at a height y, and this point is at a depth or height negative p. So this distance, all of this is just y minus negative p, which is y plus p. So this is y plus p. Distance of p to f is, we use the distance formula, which gives me x squared plus y minus p squared. And we get that by constructing a right triangle here. This is x, this is y minus p. So this distance is going to be, by Pythagoras, x squared plus y minus p squared. And now we solve this. So let's square both sides. I get x squared plus y squared minus 2py plus y squared equals y plus p squared, which is y squared plus 2py plus p squared. Now some of these terms cancel out. Y squared minus y squared is 0. This should be p. P squared minus p squared is 0. So I get x squared equals 4py. Now if you compare it to day 1 ones, in general, when we have y equals x squared, we get a parabola at vertex 0, 0. But in this particular form, this is, if you divide by 4p, it's y equals x squared divided by 4p. The reason we have all these p terms is p varies too. And what this tells us, or what this gives us additional information. It tells us where the focus is, and it tells us where the directrix is. And that's why we use this form. Yeah. For example, what about y equals x squared? Now let's see. If I compare it to this, y equals x squared. So x squared equals 1y. So 4p equals 1 and p equals 1 over 8. Which means the focus is at 0 comma p, which is 0 comma 1 over 8. And the directrix is y equals negative p. So it's negative 1, 8. The vertex is at 0, 0 because that's how we define, or we found this equation by saying that we start with a simple case of vertex being at origin. So I asked you to fill this out. If x squared equals 4py, the parabola vertex is 0, 0, focus is 0p, directrix is y equals negative p, axis of symmetry is y-axis. Because since the vertex is origin, that's the vertical line that passes through the focus. It's the y-axis. Similarly, if you change this, if you flip around the y squared, y and the x, you get y squared equals 4px. The vertex is still 0, 0, except it's going to be like that. The focus is now on the x-axis, so it would be p comma 0 and not 0 comma p. The directrix would now be a vertical line, meaning it's going to be x equals negative p, and the axis of symmetry is now going to be the x-axis and not the y-axis. Let's look at an example. Find equation of parabola with vertex 0, 0 and focus 0, 2. So just based on what is given, vertex 0, 0, focus 0, 2, meaning the focus is here. So this is, we already know, an upward facing parabola. So which form do we use? That means here, the axis of symmetry is y-axis. So we say this would be focus is 0, P is 0, 2, so P is 2. So the equation is x squared equals 4py, which becomes x squared equals 8y. So based on where the focus is, that sort of tells you which way the parabola opens, and then that tells you which of these equations to use. X squared equals 4py or y squared equals 4px. That's it for this video. Next video we're going to look at some more examples and some more things inside the parabola that can be measured.